Hello viewers, in today's session we are going to discuss another important problem from domain and a range of functions. And in this class we are going to find out the domain and range of this function f of x, which involves the inverse trigonometric functions. So here f of x is given as 2 times sine inverse 2x minus 1 minus pi by 4, and we'll see how easily we can find out the domain and range of this function by using the concept of domain and range of inverse sine function, right? So let us start. So now from the theory of inverse trigonometric functions, we know that the principal value branch of sine inverse function is given by this interval, that is minus pi by 2 to pi by 2, right? And the domain of sine inverse function is given as minus 1 to 1, right? So the inverse sine function is from this set to this set, that is the closed set minus 1 comma 1 to the closed set minus pi by 2 to pi by 2, right? So the domain of sine inverse function is given by this interval minus 1 to 1, including minus 1 and 1, and this is the range of sine inverse function, that is the closed set minus pi by 2 to pi by 2, right? So if we write here theta, then this theta must belong to this interval, that is minus 1 to 1, and we can also write this expression as theta lying between minus 1 and 1, right? And sine inverse theta belongs to this interval, right? So we write sine inverse theta belonging to the closed interval minus pi by 2 to pi by 2. So we can also write this expression as sine inverse theta. It lies between minus pi by 2 to pi by 2. So to get the domain and range of this function, we are going to utilize this result and this result. So this result will be used to get the domain of this function, and this result will be used to find out the range of this function f of x. So now to get the domain of this function, let us start with this expression, right? See, here we have a sine inverse 2x minus 1. So if we compare this function with this one, then theta is given by 2x minus 1, right? And to get the domain of this function, we need to find out all the valid values of x, right? So let us substitute this theta in this inequality. So we have minus 1, and we have 2x minus 1, and here we have 1, right? So to get the all valid values of x, we need to solve this inequality, right? So now adding 1 throughout, we have 1 plus 1, and then we have 2x minus 1 plus 1, and here we have 1 plus 1. So here we have 0, and here we have 2x, and here we have 2, right? Now dividing throughout by 2, here we have 0 over 2, here we have 2x over 2, and here we have 2 over 2. So this is 0, and here 2 and 2 get cancelled, so we have x, and here we have 1, right? So the values of x, it lies in the closed interval, that is 0 comma 1. So this is the domain of this function f of x. that is x lies between 0 and 1, including 0 and 1. So now let us find out the range of the function f of x. So to get the range of this function, we'll start with this inequality, right? So we have minus pi by 2 and then less than or equal to sine inverse theta less than or equal to pi by 2. So let us take theta is equal to 2x minus 1 in this inequality. So we have minus pi by 2, then we have sine inverse 2x minus 1 for theta, and then we have pi over 2, right? Now see, the function f of x is equal to 2 times sine inverse 2x minus 1 minus pi by 4. So let us multiply this inequality throughout by 2. So we have 2 times minus pi by 2, then we have 2 times sine inverse 2x minus 1, and then we have 2 times pi by 2. So 2 and 2 get cancelled, and we have 2 sine inverse 2x minus 1, and here 2 and 2 get cancelled, so we are left with pi, right? So now here we have an additional term, that is minus pi by 4. So let us subtract throughout minus pi by 4. So subtracting minus pi by 4 throughout in this inequality, we have minus pi by 4, and then we have 2 sine inverse 2x minus 1 minus pi by 4, and then we have pi minus pi by 4, right? Now we can see that this middle term is now equal to f of x, and if we take the function as y is equal to f of x, then we can now write minus 4 pi minus pi over 4, and this expression can now be replaced by f of x, and here we have 4 pi minus pi over 4. So this is minus 5 pi by 4, and here we have f of x, and this is 3 pi by 4. So now we can see that f of x lies between these two numbers, including minus 5 pi by 4 and 3 pi by 4. So we can also write f of x belonging to the interval that is minus 5 pi by 4 and 3 pi by 4, right? And f of x is equal to y, and y is given by the range, right? So this is the range of the function f of x. So the domain belongs to this interval, that is the closed interval 0 comma 1, and the range belongs to this interval minus 5 pi by 4 comma 3 pi by 4. So viewers, this is how we can easily find out the domain and range of these type of functions using the concept of the principal value branch of inverse trigonometric functions.